in Chapter 7 we're looking at fundamental identities. These were the identities back in Chapter 5 when we looked at sine, cosine, and tangent, their reciprocals, cosecant, secant, and cotangent, quotient identities, and then we looked at the Pythagorean identities. Right, and then we had problems kind of like this in Chapter 5 where cosine of theta equaled, say, 4/5. And I asked you to find, okay, now find tangent of theta. And we took cosine as cosine of theta equals your x over r, right? So this means x equals 4 and r equals 5, right? And then you went Pythagorean theorem and you did, okay, 4 squared plus r y squared equals 5 squared, and you went this 25, and then we subtracted 16, we got 9, and we square rooted, so our y is 3, and then we can do tangent, which is y over x. So then we found the tangent, right? I said there was another way to do it, right, where you can use those Pythagorean identities to solve for these, and the other identities to solve for. Well, basically that's what we're doing here, at least to start. And then in the next section, we're going to go ahead and use these identities to verify identities. Okay, so here are the basic trig identities. These top ones, those are our reciprocal ones. So we have sine, cosine, and tangent, and their reciprocals, right? So if we have, like, for example, the cosine of theta is equal to, what did I say, 3/5? Or 4/5, then the reciprocal of that, secant of theta, would just be flipping that 5/4, right? We've done these before. So there's the reciprocals, those 6. Then we have the quotient identities, which is just rewriting tangent and cotangent in terms of sine and cosine. And then we have the Pythagorean ones. So you'll use these Pythagoreans quite a bit. So the Pythagorean ones, what you might want to do, so there's 3 here. What you can do with this one is you can actually, you can actually take sine and solve it here. So we can solve for sine by just subtracting cosine on both sides. So sine squared of theta is equal to 1 minus cosine squared of theta. So what I would do is probably write all these formulas down on a note card or something like that so you can have them handy. So then you might, you kind of want to know them, at least these Pythagorean, the basic ones, and the other ones too are pretty easy. So, but these ones you might want to write down, the Pythagorean ones, because you're going to use them a lot and you might not be able to memorize them, which is okay. All right, so there's one form. So I took that one formula, I turned it into sine squared. So now it's solved for sine squared, and then I can solve it for square root that, both sides, and now I have 3 equations based on, I have the first one, now I have solve for sine squared, now I have it solve for sine, and then you can also do cosine, right? So cosine squared of theta would also equal 1 minus sine squared of theta, and these will come in handy. Then you can solve for cosine. So now you have, instead of 1 formula, now you're going to have 5 formulas, right? 1 minus sine squared of theta, and then square root that, plus and minus. Remember, whenever you do square root, you need a plus and minus in front of that, and then based on what quadrant you're in, what the angle is in, then you can give it a plus or a minus. Okay, so look, I turned 1 into 4 more. Okay, so you could do that same thing with these other 2 that are listed. I would recommend solving them for the other trig function, and then for the other trig function that's being squared, so I would solve this one for tangent squared, and then I would solve, well, I'd square root both sides on this one as well, and then you have, so you're going to have 1, 2, 3, 4 different equations for this one. And same thing with this bottom one here, 1 plus cotangent squared equals cosecant squared tangent. So then you can use those based on the problem that you're giving or what you're trying to prove or whatever you might have. And I'd put those on a note card or something. Okay, then we have these negative angles, and we've talked about this a little before. Sine is an odd function, meaning that if we have our unit circle here, sine is the y value, right? So that means when I have, say, an angle 30 degrees, the sine of that is 1/2, right? Sine of 30 is 1/2. Well, if I take sine of negative 30 down here, right, I just go clockwise, I get negative 1/2. So see how I just got a negative answer of the original angle? Right, so sine of 30 is 1/2. Sine of negative 30 is just negative the answer of the positive angle. Okay, same thing with cosecant, same thing with tangent and cotangent. So these are all kind of odd, what we call odd functions, right? These are odd functions. So odd functions. Then cosine and secant, they're even functions because cosine of 30 degrees is square root 3 over 2. Well, cosine of negative 32 degrees is still is square root 3 over 2. So you get the same answer. So cosine of negative an angle is the same as cosine of that positive angle. And same with secant. Okay, so those are your kind of basic identities that you're going to use here. So let's go ahead and practice some problems. Let's start with tangent of theta equals negative 5 over 3, and it's in quadrant 2. Okay, so this is kind of an example of kind of what we did back in chapter 5, where, yeah, this is your y and this is your x, and you could solve for r, and then you could find these three, and that's fine. But what I want you to do is, and kind of what I told you before in chapter 5 was the examples that we did. Well, you might want to use Pythagorean theorem or the Pythagorean identities because you're going to be using them in the next section, right? You want familiarity with those. You want to practice these quite a bit and get familiar with them. Okay, so we could do this y over x and then solve for r and find secant and sine and cotangent negative. A little bit different with cotangent negative. And we could start there if you want. But, well, let's just start at the beginning. Okay, secant theta. Well, we have this Pythagorean identity, right? That says tangent squared of theta plus 1 is equal to secant squared of theta. Well, you could rewrite these because maybe you're confused to what's being squared here. Well, tan of theta is being squared, right? So whatever tan of theta is, I'm going to square that, okay? So I'm not squaring the angle, I'm squaring whatever tan of theta is, right? And then I'm going to add 1, and that's going to equal secant of theta that's being squared. Okay, so I only want secant of theta, right? So really I need to get rid of this squared right here so I can square root both sides. So that equals secant of theta will equal the square root, so plus or minus, tangent of theta being squared plus 1. Okay, now I can't cancel that out. Like, this is not true. A squared plus b squared equals a plus b because this is a binomial, right? Square root means what times itself. So I have to figure out what times itself gets me an a squared plus b squared. So that's not true. So don't try to cancel out the square root and the squared and then square root 1, which is 1. Right? So don't try to do that. All right. So we go ahead and put in our tangent because we know what tangent is. Negative 5/3. So we're going to plug in negative 5/3 for our tangent. And then we're going to square it, right? Because it's being squared. And then we're going to add 1, and then we'll square root that after we add 1 to it. So we get 25 over 9 plus 1, and then we'll square root that. So 25 over 9 plus 1, which is just 9 over 9, right? 9 divided by 9 is 1. So we can add it. We get 34. So we get square root of 34 over 9. So that means I can square root the top over the square root of the bottom, which equals square root 34, put my plus or minus, over 3, right? And then plus or minus, so this is secant of theta, right? So we found it, but it has a plus or minus, so we need to go back and look at which quadrant we're in. We're in quadrant 2, and tangent in quadrant 2 is negative, so we can go ahead and delete this plus or minus, and we can just put negative. Okay, so there's our secant of theta. All right, now we want to find sine of theta. Well, there's no direct relationship like there was on secant and tangent with sine and tangent, but we do know that sine over cosine does equal tangent of theta. Okay, so if we could get sine by itself here by multiplying by both sides by cosine. Okay, now still we still have three different trig functions in here, but we really just want sine and cosine, just like there was secant and tangent. Well, we do have cosine, and we know that cosine of theta is equal to 1 over secant of theta. So that means if I have secant, if I flip that, then I will get my cosine. Okay, so which we do know is secant is square root 34 over 3, and it's a negative, right? So cosine of theta would be 1 over that, which just means that we just get to flip the fraction. So that's 3 over square root 34, and it's negative, right? So you could rationalize it now, or you can plug it in and wait to rationalize it. I don't care. I'm going to wait to rationalize it because then maybe I don't have to simplify as much. So tangent we know is negative 5/3. And now we know cosine of theta is negative 3 over square root 34. And that's going to equal sine of theta. Okay, so a negative times a negative is a positive. 5 times 3, well, I don't have to do that, right? Because can I cancel these 3's? So we can cancel those 3's. We get 5 over square root 34. Now I can rationalize it. Square root 34 on top, square root 34 on bottom. So we get sine of theta is equal to 5 square root 34 over 34. So there's sine. Now we can find cotangent of negative theta. So now we are after cotangent of negative theta. Well, cotangent of negative theta is just negative cotangent of just that positive angle, right? So if I can just find cotangent of the positive angle, then I can just take the negative of that answer and we're good. Well, how is tangent, what we know, and what we want to find cotangent related? Well, tangent is just 1 over cotangent of theta. Or you can switch that and do cotangent is 1 over tangent of that angle. Okay, so we know tangent. It is negative 5/3. 5/3. So that means cotangent would be 1 over negative 5/3, which means I just flip the fraction. So cotangent of theta is equal to negative 3/5. But now I want to do the negative of that. Well, the negative of that is just taking negative of the answer. So maybe I'll get that. So that's cotangent of theta, but we want cotangent of negative theta. Well, that means I just take negative of the answer of cotangent of that angle, which is negative 3/5. So we get cotangent of negative theta is negative times negative is positive, just positive 3/5. And so there is our answer. Okay, so here's another problem that you're going to be dealing with. And here, so here we don't have like cotangent of x. You can put theta, whatever. Cotangent of x is not equal to some type of fraction or some number, right? It's just cosine. And we want to write that in terms of tangent. What that means is I want to solve for cosine, okay? But I want my answer to have a tangent, only tangent in it, okay? No other trig function. I just want cosine equal to some form of tangent. It could be 1 plus tangent, blah 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 blah. It could be a whole bunch of different things. And that's what we're gonna figure out. Okay, but in terms of just means basically that our variable is gonna be tangent. Okay, so how are these kind of related? Well, they're related just like the second one, right? Or the one we did previously. Cosine is 1 over secant, right? So cosine x is 1 over secant x. And if we squared that, if we squared cosine, then I would have to square the the secant, right? If it's cubed, then that would be cubed. So just that follows with all of these basic identities, if on the reciprocal ones and the quotient ones. If you have, so tangent squared is equal to sine squared x over cosine squared x. If it was cubed, then these two would be cubed. Okay, so that's just a little sidetrack, sorry. Okay, so because I squared that, right? Even though I'm just trying to find cosine, I'm not trying to find cosine squared. But if I square the cosine, then I square the secant, and I know that secant and tangent are related, right? Because secant squared x would equal 1 plus tan squared x, right? So if secant squared x equals 1 plus tangent squared x, then I can substitute secant squared x for 1 plus tangent squared x. So that means cosine squared, so I'm taking this one, squared x will equal 1 over 1 plus tan squared x. So look, I almost have cosine by itself, right? How do I get rid of the squared? Well, I just square root both sides. And when I square root, I put a plus and minus in front. So there's some different ways that you can go about this and rewriting this and solving it. But some might be other, you know, for some people's brains, maybe one way is easier, maybe for a different person another way is easier, right? But you should be able to get to the same exact thing. And if you don't, that means somewhere you went wrong. So I can take the square root of the top over the square root of the bottom. And square root of the top is just 1. So I'll just leave the plus and minus on the bottom, but I can put it anywhere. Okay, then you might say, so we can leave it like that, but you might say, hey, there's a square root on bottom. Well, how do we get rid of that square root? We multiply by the same thing, right? Because square root is looking for pairs. But I got to multiply top and bottom. So that means on top I would get a square root of 1 plus tan squared x, but on bottom the square roots are going to cancel out. I get left with my radicand, 1 plus tan squared x, and then a plus and minus. I can just put that out front or on top, or on if I put it on bottom, I just put it in parentheses. So that is cosine x in terms of tangent. So notice that I have cosine solved for cosine, and it's in terms of tangent, meaning my answer only has tangent in it. So either one of these would be fine. Okay, so last example before we do some homework problems. So looking at rewriting this 1 plus cotangent squared of theta divided by 1 minus cosecant squared of theta in terms of sine and cosine, and we don't leave it as a fraction. What I mean by that is basically don't just switch this. So cotangent we can rewrite as with the quotient identity as 1 plus cosine of squared, because that cotangent is squared, so that means this cosine has to be squared of theta, divided by sine squared of theta over, and I can rewrite cosecant, right, using my reciprocal one. Since that's squared, that means 1 over sine has to be squared. Okay, so there, it's in terms of sine and cosine. So that's why I told you not to leave as a fraction, because I want you to keep on going. At the very end, you could leave in terms of, basically this is going to simplify to secant, negative secant squared of theta. But okay, we'll just keep going. All right, so like I said, there's several different ways that you can do this, right? Excuse me. There is a formula right here that I can switch, right? A Pythagorean identity that I could switch right away, right? I could switch that right away to cosecant squared of theta if I want to do that. But then I need to figure out, okay, how do I get rid of the bottom one? Well, doing it this way that I did, right, I want to get rid of that denominator. So how do I get rid of dividing by sine squared of theta? Well, I would multiply by sine of squared of theta. But if I want to do that, wouldn't I have to do that to the whole top? And if I do it to the top, in order not change the value of this, wouldn't I have to also do that to the bottom? So basically, I'm going to multiply every term by my common denominator. We did this back when we were doing algebra, usually in complex complex fractions, right? Fractions inside of fractions. We multiply by the LCM, least common multiple, on every term. So we're going to multiply everything by sine squared of theta. Okay, so that means this becomes sine squared of theta plus this sine is going to cancel with this sine squared, so we just left with cosine squared of theta over sine squared of theta minus this sine squared, and this sine squared is going to cancel out. 1, just 1, minus 1. Okay, but you have to make sure you multiply it by, don't just cancel this out, sine squared, and then say, oh, I don't have to multiply by 1. You're still distributing it to both of them, right? Okay, and then we can look at our Pythagorean identities again. What do we see? Well, this isn't that just equal to 1, right? Pythagorean identity. So our top is 1. Now, this bottom one almost looks like something. It almost looks like this. But my 1 is positive. Here my 1 is negative. My sine squared is negative. This is negative. Well, can I just times that by a negative on the right? And if I times it by on the right, I have to times by the left. So negative cosine squared of theta would be a negative 1 and a positive sine squared theta, which is that, right? Which is the denominator there. So I can switch that denominator for negative cosine squared of theta. So there, it's in terms. So now you could be done if you wanted to. But I did say no fractions, so you can go ahead, right? You have cosine squared of theta. You have 1 over that. So if I flip this, wouldn't I get secant squared of theta and negative secant squared of theta? So that would be your final answer. Or you can leave it right here. It would be fine too. Okay, so let's go ahead and do some practice problems. Okay, so here's some practice problems to work on: 7, 15, 31, 53, 65 through 73 odd. So we'll go ahead and work on a couple of these to practice. Okay, so here's number 7. Cosine of theta equals 3/4, and theta is in 1, so that means we're trying to ask to find sine of theta. Okay, so that means that our answer is going to be positive because we're in quadrant 1 and everything's positive in quadrant 1. So you could do, x over r, and you could do that, or you can use the fact that I asked you to take this formula or this identity and solve for sine. And wasn't sine, it was sine squared of theta equals 1 minus cosine squared of theta, and then I had you square root that and put the plus or minus. We know because we're in quadrant 1 that it is just going to be positive, so we can go ahead and delete that plus or minus. Okay, so that means all we're doing here is really just squaring our cosine, which is 3/4, and then subtracting 1 from that, and then square rooting it, and that will equal sine of theta. Okay, so 1 minus 3/4 squared, right, because cosine is 3/4. Cosine of theta equals 3/4, and then we're squaring that. Then we're going to subtract 1. So 1 minus 9/16, and then we'll square root. So we get 16 over 16 minus 9 over 9, or 9 over 16, right? Because we need that common denominator, and then we'll square root. So we get, what, 7 over 16, and then we square root it, and we do the square root of the top over the square root of the bottom, which is equal to the square root of 7 over 4. So there's our answer. Sine of theta is equal to square root of 7 over 4. But you can do that, right, if you squared this, and you squared, well, it's over 4, so 3 squared plus x squared equals, oh, that is our x, I guess, so that'd be y, and that'd be 4 squared. So 9 minus 16 is 7, so our y is equal to square root 7, right? If you did the x, y, and r thing. Okay, but we use the Pythagorean identities. Okay, so there's our answer for number 7. Okay, here's number 15. We're looking at secant of theta is 11/4. So we want to find, we're still looking to find sine. So we're trying to find sine of theta. And cotangent is negative, right? So when cotangent is negative, that means we're either in the second quadrant or we're in the fourth quadrant. Okay, if cotangent is negative. Okay, so that means sine would be positive or negative, because it's positive in the second but negative in the fourth, right? So our answer is probably going to be a plus and minus. Okay, and we can see, well, actually no, because we know that secant is basically looking at our x, right, because it goes with cosine, is positive, so that means that we're actually in the fourth quadrant, and so cosine is actually going to be negative, right? So our answer is going to be negative. All right, well, how does sine and cosine, compare to each other? Well, they don't do it directly, right? But I know cosecant, secant, SEC, secant, is equal to 1 over cosine of theta, and our secant is 11/4. Or maybe another way to do it is cosine of theta equals 1 over secant of theta, and secant of theta is 11/4. So 1 over 11/4 would be cosine of theta. So that means cosine of theta is 4/11. And cosine and sine are related, right? By the Pythagorean identity that says sine squared of theta plus cosine squared of theta equals 1. Well, these aren't squared, and we just did the last one of finding for sine is right square root. We know it's going to be negative because we're in quadrant 4. 1 minus cosine squared of theta, so we just need to square this. So we get 16 over 121, and we're going to subtract 1 from that, and then we're going to square root. So we can get 121 over 121 minus 16 over 121. And then we subtract those, so we get what? 105 over 121. Square root it. We know our answer is going to be negative. So negative square root of the top over the square root of the bottom, and square root of 121 is 11. So we get sine of theta is equal to negative square root 105 over 11. So there's our answer. Okay, number 31, we have sine of theta equals 2/3, and we're asked to find all the other remaining 5 trig functions, and we're in quadrant 2. So since we're in quadrant 2, that means that sine and cosecant are the only positive ones. So let's go ahead and find cosecant. That would just be flipping it, right? So 3/2. So those are only positive ones. All the rest will be negative. Okay, if I know sine of theta, that means that cosine of theta we know is going to be negative, and it's the square root of 1 minus sine squared of theta. So I got to square that. So that's 4/9. I got to subtract 1 from it, then square root it. We know it's going to be negative. So we get 9/9 minus 4/9. So we get 5/9. And then we're going to square root that, 5/9. So that's square root of 5 over the square root of 9, which is 3. So negative root 5 over 3 is cosine of theta. And now we can flip that and do secant of theta, which is just negative 3 over root 5. We can rationalize it, multiplying by root 5. So secant of theta equals negative 3 root 5 over 5. Okay, and then tangent, you could do several different things with tangent. We could use the secant that we just found and use the Pythagorean identity of 1 plus tangent squared equals secant squared. That's fine, but we do know sine and cosine. And since we do know sine of theta and cosine of theta, then we can go ahead and find tangent, right? Because we have this quotient identity. And we can also find cotangent, which is just cosine of theta over sine of theta. Right? So we know sine is 2/3. We know cosine is negative root 5 over 3. Don't have to worry about the negative because we know tangent of theta is going to be negative. Same with cotangent. We know it's going to be negative because we're in the second quadrant. Okay, so whenever we divide by fractions, we just flip the bottom one and multiply. So 3's cancel out. We get 2 over negative square root 3, multiplied by square root 3 to rationalize that denominator. So we get negative 2 root 3 over 3. Then we can go ahead and flip that, right, because they're reciprocals. I don't really have to do this one because I can just flip cotangent when I find it. Well, I'm actually going to flip this one, right, rather than this rationalized one, because then I'm going to have to rationalize it again. So I'm going to take the root 3, negative root 3, and put it on top. And then I'm going to divide that by 2. So I'm just flipping that one. Okay, so they're the rest of the 5 for you. Okay, here's number 53. This is actually easy because you already did it in the last problems. Right, write sine in terms of cosine. How are sine and cosine related? Well, they're not directly related, but sine squared is equal to 1 minus cosine squared of theta, or x, whatever your angle is, whatever you're using for your angle. So this is the angle, this is the angle. Then we square root, right? Boom. This is done, plus or minus. So that one's done. Right, I would practice maybe some other ones. That's probably a good thing to do. So 53 through 58, right? If you can write them like that, that means when you have problems later on, you can do direct substitutions, right? And I can use these identities. All right. Okay, looking at number 65, we're asked to take this sine squared of theta times cosecant squared of theta and put it in terms of sine and cosine and simplify that no quotient remains our final expression. So no fractions. And then minus 1 here. Okay, so we can perform some algebra, right? We can distribute this to both of them. So we have sine squared of theta times cosecant squared of theta minus sine squared of theta. So cosecant squared of theta is just 1 over sine of squared of theta. So really, I'm taking sine squared of theta and I'm dividing by sine squared of theta. So those are going to cancel out, right? Reciprocals always cancel out, right? 2 and 1/2, they cancel out. They're reciprocals. Negative 3 and negative 1/3, those are reciprocals. Those cancel out, right? And you get 1. Same thing here, so we get 1, and then we have minus sine squared. Well, what did that equal? We kind of just did it, but with sine, this equals cosine squared of theta. So there's our final answer. Okay, here's another one. We can go ahead and perform the algebra because we don't have any direct substitutions, right? Because this is not a squared, and this is not a squared, so we don't have any direct substitutions. So we can't just, those Pythagorean ones are squared, right? So we can't just multiply by cosine because I can't multiply by a second cosine because then I have to multiply the 1 by it, right? So what we're going to do is just going to FOIL these out. Distribute that to both of them, distribute this to both of them, right? So we're going to FOIL this out. So we get 1 times 1 is 1, 1 times secant is positive secant of theta, negative cosine of theta times 1 is a negative cosine of theta, and negative cosine times secant is negative cosine theta times secant of theta, which they are reciprocal, so that's going to cancel to 1. So then we have 1 minus 1, which is 0, so then we just have secant of theta minus cosine of theta. Okay, so there is our answer. It's in terms of sine and cosine because really secant is just cosine. It's 1 over cosine, right? So that's in terms of sine and cosine. So this is just our final answer here. Okay. Okay, so here we have number 69 here, and we're trying to find, just simplify in terms of sine and cosine. So we can deal with this negative theta, right? That is just negative tan of the positive angle. Same thing with the bottom, negative tan of the positive angle. So then this is just 1 minus, because the positive times negative is negative, tan of theta over negative tan of theta. So now we need to put it in terms of sine and cosine. What we can do, kind of like what we did in the example, we can rewrite tangent, because these aren't squared, so we have no direct relationship. We can write tangent as sine of theta over cosine of theta, and negative tan as negative sine of theta over cosine of theta. And then here it's a little bit different than our example that we did, because on our example we had a binomial, two terms, right, over two terms. So there we that's why we multiplied by the least common multiple, right, sine squared. But here we don't have any squared. So here a little bit different, because I only have one term on bottom. So since I only have one term on bottom, remember when I'm dividing by a fraction, I'm multiplying by the reciprocal. So I am going to take the denominator and just flip it and multiply the numerator by that reciprocal. So that means I'm distributing this to both. So that means I get a negative cosine of theta over sine of theta, and then a positive, and when I distribute that, the cosine will cancel out and the sine will cancel out, where I get 1. And then this will just simplify to cotangent. And so there's my answer. Okay, so here we go, number 71. So now if I look at these, numerator and denominator, these are direct relationships, right? 1 minus cosine squared of theta, even though it's negative theta, is still, we can deal with that actually right now, right? Because this is going to be the same with cosine, because it's an even function, as the same as this. Now tangent's a little different. We'll hold off on tangent. We'll keep that we'll keep that right there, and then we'll go ahead, and now that we have direct relationship, right, this is equal to sine of theta, sine squared of theta, and bottom one would be secant squared of negative theta, right, because my tangent's negative theta, so my secant would be negative theta. Now secant is a positive function, just like cosine, or an even function, sorry. So that means that's going to be turned to positive now theta, because it's an even function. So we have sine of theta over secant of theta, and now we can switch that. Secant of theta can move to the top and become cosine of theta, and it's squared. These are squared, sorry, squared. And so there's our answer for number 71. Now we can look at number 73. Last one here. Taking secant of theta, subtracting cosine of theta. And so what we can do here is we can switch this, okay, to 1 over cosine. So secant becomes 1 over cosine of theta. Now here we want to do some algebra. We have a fraction minus a whole number, right, basically. Right, so like 1/3 minus 2, combine these into one fraction, right? So we have to multiply top and bottom of this one by cosine to get a common denominator as cosine. So that top becomes negative cosine squared of theta. Cosine times cosine is cosine squared. So we have 1 minus cosine squared of theta over cosine, which is sine squared of theta over cosine. We don't want to have a fraction at the end. So I can separate this. Now this is, I have two signs up top, right? I have sine of theta times sine of theta over cosine. Now this, here we had a binomial. Here we still have a monomial, right? We just have one. It's just multiplication. There's a subtraction on the top there of 1 minus cosine squared. This one is being multiplied, so we can easily write this as two fractions, but they're going to be multiplied, right? So I could do sine of theta over cosine of theta times sine, right? Because I'm multiplying, I don't need a common denominator, right? And sine over cosine is tangent of theta, and then times sine. So there's our final answer. Tangent of theta times sine of theta. All right, all done.